All right, graphing number 5, f of x equals x squared plus 2x minus 8 over 4x squared minus 16. First thing we're going to do is factor the numerator and denominator. So up top here, you can factor this. We have an x times x gives us x squared. We want to get negative 8, so it looks like this will be a plus 4 and a minus 2. In the denominator, there is a 4 in common, so we can factor out a 4. That leaves us with x squared minus 4. Hopefully we can, well, we'll just put it down here. We have x plus 4 over x minus 2, and then x squared minus 4 factors to x plus 2 times x minus 2, which we actually see we have a common factor of x minus 2. So now we're going to write down our things here. We want to check for holes. We want to check for our zeros, which are x-intercepts, the vertical asymptotes, and a horizontal asymptote or a slant asymptote, whichever one occurs here. So, holes. We're going to look for holes. Those are values that make the canceled factors equal 0. Well, we did have some canceled factors here. What value of x made that equal 0? Well, x equals 2 makes that equal 0. So we're going to have a hole at x equals 2. What I'm going to do here is, we don't know exactly where that's going to go. I'm going to put a circle there on 2, just so I remember to incorporate that hole after I finish graphing. Next, we're looking for zeros. Well, now we're just looking at this highlighted part. So values that make the numerator equal to 0. So looking at the numerator, we have x plus 4, well, x equals negative 4 would give us a 0. And then, so we got that done. Now we're going to look for vertical asymptotes. That's values that make the denominator equal 0. Our denominator has an x plus 2, so x minus 2 would be a vertical asymptote. So we'll go ahead and put that in there. So we got that done. Now we're looking for a horizontal or slant asymptote. All right, to look for the horizontal or slant asymptote, we need to look at the degree of the numerator and the degree of the denominator. So looking at, you really can look at the original, but looking at our canceled part here, the degree of the numerator ends up being x to the first, and so does the degree of the denominator. So they are both 1. Well, looking through our different choices here, we have the degree of the numerator is equal to the degree of the denominator, which gives us a horizontal asymptote at y equals this fraction. So y equals the fraction of the leading coefficient of the numerator over the leading coefficient of the denominator. Leading coefficient here is 1. If we distributed this in, the leading coefficient is 4. So we have a horizontal asymptote at y equals 1/4. So pretty close to the x-axis. Y is equal to 1/4. And then let's find a y-intercept. So down here at number 6, find a y-intercept and other helpful points. So we defined a y-intercept, we plug 0 in for x. Back to our original, if we plug 0 in for x, these 3 terms would not be there, and so we would just be left with negative 8 over negative 16, which is 1/2. Same would work out in our new equation. If you put 0 in there, you would get 4 over 8, which is 1/2. So we have a y-intercept at 1/2. Just above our horizontal asymptote. Well, now we can graph this. On the left side of the vertical asymptote, looks like this function has to go through the x-axis at -4, but it also has to be asymptotic towards that horizontal asymptote. So there's the left side of 0, and then to the right of that 0 at -4, it has to get closer and closer to our vertical asymptote. If we wanted to be even more accurate, we could plug -3 into our function to find out where the graph is at x equals -3. Now on the right side of the asymptote, the vertical asymptote came from x plus 2, which the multiplicity is just 1. And so to the left and right of the asymptote, the function goes in opposite directions. So as we see here, the graph goes down on the left, so it has to go up on the right. And it has to pass through the y-intercept and then get closer and closer to the horizontal asymptote. Now I do notice here I have this circle on -2 to remind me that there's a hole, at +2, at 2. So I'm going to put an open circle there at 2 and then keep my graph going closer and closer to the horizontal asymptote. And I'm going to go ahead and erase this earlier circle at 2. So there is the graph for f of x.